Hello students, this is our last lecture for chapter number 2. Let us start with topic number 2.9, dimensions and dimensional formula. Now for what these dimensions and the dimensional formula used, and what is this dimensional formula? So here I have written that the formula which represents length, mass and time in terms of its symbol. That means those formula which relates these physical quantities in terms of their symbols, special symbols, are called a dimensional formula. Now here not only the special symbols are used, but along with this symbol there is a related exponent, means their respective powers are also there. So here symbol for mass is taken as m, symbol for length is taken as L, symbol for time is taken as T, symbol for current is taken as A, and symbol for temperature is taken as K. So these are the physical quantities and these are their symbols to obtain the dimensional formula. Now students, mostly mass, length and time are used, but whenever there is a concept of electric current or temperature, then even A and K are also used. Now let us understand more effectively about these dimensions and dimensional formula. Students, we know that every physical quantity can be related with some formula, and if there is a formula it has its unit also, and hence there is a dimensional formula also can be obtained. Let us see with some examples. Here I have taken an example of a velocity. Now students, we know that a simple formula for the velocity is distance upon time. So if I want the dimensional formula of velocity, then I can write this as symbolically like this. This square bracket means we can read it as dimension of velocity. So if I want dimension of velocity, then on the right hand side there are two physical quantities, distance and time. So we need the dimension of distance upon dimension of time. Now for distance, what can be used? Definitely the symbol is L. So here I have used L. If there is no power, means power is 1. Time, symbol for time is T, and if there is no power here, means power is 1. Finally, I will write the dimensional formula for V, or simply we can say dimension of V as MLT. Students, remember always the dimensions are represented in terms of MLT. But here you can see in this equation there is no M, there is no mass. So M is written here, but its power is 0. For simplicity, we used to write this, but we have to put the power 0 because there is no mass. For L, it is L raised to 1, you can see here, and time is in denominator. So when we write T here, it is T raised to minus 1. I hope you understood this. Now, unit distance is measured in term of meter, You can see from the formula, distance is always in meter and time is in second. So unit of velocity is meter per second. Or you can check like this also. Here there is a length in the dimension of velocity. So length means it is measured in meter, and here there is inverse of time, and time is measured in second. So inverse of time is taken, so upon second. So you can check in either ways. Let us take second example. Area is a physical quantity, but area, its simple formula is length into breadth. We know that if there is a rectangle, then this is its length and this is its breadth. So if you multiply L into B, then you will get area. So a simple formula for area is L into B. Now I want the dimensions of A. Then what is here first? L. So dimension of L into what is here next? B. So dimension of B. See, L, length, its dimension can be represented as capital L symbolically. So I have written here L. Similarly, breadth is also having symbol L. So it is L only, because these are measurements of length only. L or B or radius or height or diameter, their symbol is L only, because they all have unit meter, and so symbol is L. So L raised to 1 here also and L raised to 1 here also. So finally it is L raised to 1 plus 1 power is 2. Now we want to represent this area in terms of its dimensional formula. So we will write M, L and T first, because usually we represent the dimensional formula in terms of M, L and T. So first you have to write MLT simply. Then here you can see there is no mass, so M raised to 0. There is no T here, so T raised to 0, and power of L is 2, so here it is 2. Now about unit. Unit, simple, from the formula, length is measured in meter, so 1 meter is there. Breadth is measured in meter, so again into meter, and meter into meter is meter square. In other way, you can see that in dimensional formula there is only L square, and L means length. Length is measured in terms of meter, and L square, so here meter square. So students, if there is a formula known to us, then we can get the unit also for that physical quantity, as well as we can easily obtain the dimensional formula. Now for volume. To obtain the dimensional formula of volume, first we will write a simple formula of volume. We know that volume of a cuboid is given by LBH. Now we know that L is also measured in meter, breadth is also measured in meter, and height is also measured in meter. So unit of all these three is same, and so meter into meter into meter is meter cube. So unit of volume is meter cube. And now directly from this unit you can write the dimensional formula. For that, first you have to simply write MLT, because we know that the dimensional formula is always in terms of MLT. Now here meter cube means it is for length, and so L cube is written here. from unit, it is clear that there is no mass and no time. So power of m is 0 and power of time is also 0. Now about density. To obtain the dimensional formula of density, we will choose its simple formula. According to definition, density is mass upon volume. So to find the dimensional formula of density, we will write dimension of mass upon dimension of V. For mass, its dimension is m raised to 1, and for volume the dimension is L cube. From where this L cube is obtained for the dimension of V, that we have seen in this case, that the dimension of volume is L cube. So directly we have taken that. Now combining these two, and so now writing m, L and T, and then here power of m is 1, so 1, power of L is 3, but it is in the denominator, so we have to write minus 3, and there is no T here, so T raised to 0. So dimensional formula of density is m1 L minus 3 and T raised to 0. Now about unit. Unit can be obtained from the dimension directly, or dimension can be obtained from the unit, vice versa. Both can be done. Even unit can be written from the formula also. Mass is in kg, so we have written it kg, and volume is in meter cube, so we have written meter cube. You can also write from the dimensional formula also. Now next example, acceleration. Now a simple formula for acceleration is change in velocity upon time. Students, whenever velocity changes with respect to time, it gives acceleration. So here I have used a simple formula for acceleration, and now dimensional formula of acceleration. Which quantity is here in numerator? It is velocity. So dimensional formula of velocity upon, there is time, so dimensions of time. Now velocity is m0 L1 t raised to minus 1. How? This we have obtained in number 1 example. So we have directly written here. For time it is t. Now combining these two, we can write this. M power is 0, so 0. Here L is 1, so L power is 1, and time here minus 1, but even for this denominator, if we'll bring that in numerator, so already one power is minus 1, and the second power for that denominator time, that is also minus 1, because when we'll bring from this denominator to numerator, the power will become negative. So minus 1 and minus 1 will become minus 2. So dimensional formula of acceleration is m0 L1 t raised to minus 2. Now about unit. So from dimensional formula we can directly write the unit, as there is length, and length is measured in meter, t raised to minus 2, and time is in second, so s raised to minus 2. Now about force. Force F is equal to mass into acceleration. So first we'll write simple formula for the force. Now to find the dimensional formula. Dimensional formula of force is equal to dimensional formula of mass into dimensional formula of acceleration. Dimensional formula of mass is m raised to 1, and for acceleration it is m naught L1 t raised to minus 2. From where we obtain this? We obtain this from here. Already we have the dimensional formula of acceleration, so we can directly use it. Now students, one more thing. If here you will not write m naught, then also it is okay, because anything raised to 0 is 1. So no need to write that 1 here. So if you will simply write this and only this, then also it is okay. Now finally m power is 1, so here written power 1, L raised to 1, so it is here, t raised to minus 2, so it is here. So finally we can say the dimensional formula of force is m1 L1 t raised to minus 2. Now about unit. From the formula also you can write the unit, or from the dimensional formula also you can write the unit. Here there is mass, so mass is in kg, length is in meter, and time is in second. So t raised to minus 2, so second raised to minus 2. So unit in SI system is kg meter per second square. But the special unit of force is Newton. 1 Newton is equal to, definitely it is 1 kg meter per second square. But the concepts of force and the laws were given by a scientist Newton, and that's why on his name the unit of force is taken as capital N. Now dimensional formula of work. Now students, we know that work can be converted to energy, or energy can be converted to work. So the unit of work or the energy is same, as well as the dimensions also same. The formula for work can be different, the formula for energy can be different, even different energy may have different formula, but their dimensions will be same. If I use kinetic energy K, its formula is half mv square. If I use potential energy U, then U is mgh. You can see here, this is kinetic energy, this is potential energy. The formula for both are different, but if you will obtain the dimensional formula using this, then also you will get this. If you will use this formula, then also you will get the dimensional formula same. Or if you will use the dimension for work, then also that will be same, because work can be converted to energy, or energy can be converted to work. So you can use any formula to obtain the dimensional formula of work or energy, but here I am using a simple formula. Work W is equal to force into displacement. Now dimensional formula of W is equal to dimensional formula of F and dimensional formula of D. Now we know what is the dimensional formula of F. we have already obtained here. And so if we are able to remember this formula, then directly we can write here that dimension of f is m1 l1 t raised to minus 2, and for distance it is l. Now combining these two, we can get the dimension of work or the energy as m, its power is 1, so as it is. Here L power is 1, but there is one more L whose power is 1. So 1 plus 1 is 2. So here L to the power 2. T raised to minus 2. So as it is. So dimensional formula of work or energy is M1 L2 T raised to minus 2. Now about unit. From the formula also you can write the unit. Force is given by Newton, that is unit of force is Newton, and distance is in meter. So unit of work can be written as Newton meter, or you can see from this dimensional formula, mass is in kg, length is in meter, but here there is square, so here also meter square. Time is in second, its power is minus 2, so here also minus 2. So unit of work can be written as kg meter square per second square. But once again, on the name of the scientist Joule, the unit of work or the energy is taken as joule. In symbol we can write capital J. Next is about power. Now students, formula for the power is work done per unit time. So power P is equal to W upon T, and so dimensional formula of P is equal to dimensional formula of W upon dimensional formula of T. Now what is dimensional formula of W? We already obtained here, so directly we can use if we are able to remember this. So dimensional formula of W I have written here, for time I have written here, and now combining these two, we can write this as m1 l2 t raised to minus 3. Here there is t, so when we write that t here, its power will become negative, so already minus 2 is there, and one more minus 1 is added to this, so t raised to minus 2. Now about unit. From formula, what is unit of work? So we know that it is joule, and for time it is second. So unit of power is joule per second, or specially we can write as watt, on the name of scientist James Watt. The unit of power is generally written as watt. If you write this, then also it is correct. So now students, I hope you understand how to obtain dimensional formula and the unit from the given formula or the formula which you remember. So it is quite easy. If you'll do more practice, you will find same as more easy. So do practice for more formulas and their dimensional formula as well as unit. In the notes I have given many physical quantities like pressure, frequency, momentum, and so on. Now you can easily obtain their dimensional formulas. Now students, for what purpose this dimensional analysis or the dimensional formula is used? So now we will see that applications of dimensional analysis. Now here remember that the first point, what it says, during addition or subtraction it is possible only for those physical quantities whose dimensions are same. Means student, addition and subtraction are between the same physical quantities which have same dimensions. That means it is similar to the mathematical operation of like terms. You have studied till 10th standard that addition or subtraction is carried out only between the like terms. Means if I want to add x plus 2x, then it is possible. The answer is 3x. But if I want to add x plus 2y, then it is not possible, because x and y, they are different variables. So after this it is not possible to obtain the result. So similarly here also I have given these examples so that you can easily understand this. Suppose a physical quantity is given and their addition is shown. Suppose the addition is 5 meter plus 10 meter. So students, here you can see the unit is same. As unit is same, their dimension is also same. And so these two can be easily added. 5 plus 10 is equal to 15 with the same unit which is having this or this. So this type of addition is possible. One more example, 9 centimeter minus 15 millimeter. Now we know that centimeter is also for length, millimeter is also for length only. So these two have same dimensions, that is L. So we can add these two. But before adding, we know that we need to convert either this centimeter to millimeter or this millimeter to centimeter. So what I did here, I converted this 50 millimeter to centimeter, which is equal to 1.5 centimeter. And so now 9 centimeter, that is here, minus 1.5 centimeter, which is converted from this, that will be equal to 7.5 centimeter. Next is about 5 centimeter and 10 gram. So students, see, this is having different dimensions. Centimeter is having dimension L, gram is having dimension of mass. So as here there are different dimensions, these two cannot be added. So this type of addition, or if there is a minus sign here, that is subtraction, then even that is not possible. I hope you understood this. Now for multiplication and division. Students, remember that multiplication or division can be carried out between any physical quantities, even with different dimensions also. That is, multiplication can be carried out for like terms as well as unlike terms. in the language of mathematics. So if two physical quantities have same dimension, then also multiplication or division can be carried out. Or if they are having different dimensions, then also this operation, that is multiplication or division, can be carried out. Now let us see example so that you can understand it properly. Suppose here first physical quantity having measurement 5 meter and the second physical quantity having the measurement 2 meter, and these two are to be multiplied. So in this case you can see that both are having dimension length, because here unit is meter, here also unit is meter, so both have dimension of length, and so we can multiply it. 5 multiplied by 2 is 10, and meter into meter is meter square. For second, first measurement is 10 gram and second measurement is 5 centimeter. You can see the first is in gram, second is in centimeter. Gram has the dimension of mass, centimeter has the dimension of length. So here you can see that these are having different dimensions, and here we have to divide both. So in that case we can divide it, because this rule says that you can do multiplication or division with any type of physical quantity. Now 10 divided by 5 gives 2, and gram upon centimeter, so it is here. Next is, there are two physical quantities. The measurement of first is 5 kg and that of second is 100 gram. You can see here this 5 kg, that is kg means its dimension is of mass. Gram, again it is dimension m, mass only. So both are having same type of dimensions. There is division in between, but we know that the unit should be same. So what we'll do, either we can convert this gram to kilogram or this kilogram to gram. So here what I did, I converted kilogram to gram. So 5 kg is equal to 5000 gram. So I have made this conversion. Now unit is gram here, and here also it is gram. 100 gram, that is here. Now simple division is made. This divided by this, so 0 0 cancel, here also 0 0 cancel, remain is 50. So answer is 50, but here gram and gram also cancels. So students, here there is a printing mistake. Make this correction in my notes also. Here this gram will not be there. This is any constant number now, because here this gram divided by gram will also cancel. Now I hope student you understood this. Now what is to be remembered here? So I have written note. In addition or subtraction, dimensions of the resultant physical quantity will remain same. The dimensions, they remain same as those of which are given for addition or subtraction. We have seen that in example also, that if the addition or subtraction is possible, then see here also meter, here also meter, result is also meter. If it is possible, here also it is in centimeter, here we have converted this into centimeter, and here finally also it is centimeter, means the dimension remains same. For length, here also length, result is also length. Is it clear to all of you? But for multiplication and division, the dimensions of the resultant physical quantity will change, and resultant dimension is the product or the division of the same, and that we have already understood with these examples. So students, I hope there will not be any problem for you to understand this. Now about next topic, that is about the applications of dimensional analysis. So now how we can apply this dimensional analysis? So here it is given that we can check the dimensional consistency of any given equation. Means if any formula or the equation is given to us, then we can check it whether this formula is correct or not using dimensional formula or dimensional analysis. So students, with the help of this dimensional analysis, we can primarily check this. So students, with the help of this dimensional formula, we can check initially or the primary test of the equation, that if the given equation can be correct or not. So that can be made by this analysis, but this does not give any guarantee of the correctness. The equation is exactly correct or not, that guarantee is not given by this analysis, but preliminary test can be done. Now why it does not give any guarantee? It is because in some equation there are special functions such as trigonometric, logarithmic functions, even exponential functions are there, and even some constants are also there in a formula. So this analysis does not give any information for such type of things. Now example number 2.15. Here this equation is given: half of mv square is equal to mgh. Here we have to check that whether this given equation is dimensionally correct or not. So to check this, we will first obtain the dimensions of left hand side term and then the dimension of right hand side term. Students, if this equation is correct dimensionally, then all its terms must have same dimension. Here only two terms are there, on left hand side and on right hand side. There may be more than two terms also in a equation, but for the equation to be correct dimensionally, all the terms should have same dimension. So now first let us check the dimension of left hand side term. Dimension of half of mv square is equal to dimension of m. Why m? Because here it is m there. Then dimension of v and its square. Now students, here you can see there is 1 by 2, but this 1 by 2 is a constant number, and this type of numbers have no dimension. So that type of constants or the numbers are not to be considered. So here we have considered only m and v. Now dimension of m, that is mass, is m and power is only 1. No power given means power is 1. What is v? V is distance upon time. So distance is L and upon time means power minus 1. We have already seen what is the dimension of velocity in earlier examples. So that we have written here, distance upon time. For distance we have used L. Now combining these two and writing the final result in terms of m, L and T. M has power 1, so we have written here 1. L has power 2, because if we will open this bracket, then 2 ones are 2, so L raised to 2 here, and then 2 is also multiplied to this. 2 into minus 1 is minus 2, so T raised to minus 2. So here we obtained dimension for half of mv square, which is on the left side. Now dimension on right hand side term, mgh is given, so its dimension is dimension of m, dimension of g and dimension of h. M is mass, so here we have written m capital, because for mass the symbol we use as capital M. What is g here? It is given in the statement. G is acceleration due to gravity. It is acceleration, and acceleration has the dimension distance upon time square. So distance upon means inverse, so t raised to minus 2, and height is having dimension L, because unit of height is meter and meter is taken as capital L. So in that way you can remember. Now combining all this and writing in terms of m, L and T. M raised to 1, L here it is power 1 and here also it is power 1, so 1 plus 1 is 2, so power of L here is 2, and only remain T raised to minus 2, and that is kept here as it is. Now you can see here both left hand side and right hand side, they are having same dimensions, and so we can say that the given equation is dimensionally correct or dimensionally valid equation. Now example number 2.16. In this example there are 5 equations for kinetic energy are given, and here we want to check that which of these given equations can be correct dimensionally. So for that what we will do, we will obtain the dimension of kinetic energy K, and also the dimensions on the right hand side terms which are given in each equation, and after obtaining their dimensions will compare their dimensions with that of K. If the dimensions are equal to that of K, then we can say that that equation is dimensionally correct. But if the dimension does not match with K, then we can say that that cannot be the equation for kinetic energy. One more thing, here in this equation E, there are two terms on the right hand side, so we have to check the dimension of both the terms and then compare with K. We have to compare dimension of this term with K as well as this term with K. Both should have same dimension. So now let us start. Here it is given that kinetic energy, its unit is joule, that is given in the statement, and joule means it is kg meter square per second square. So from this unit we can easily say that the dimension of kinetic energy K is equal to m1 L2 t raised to minus 2. Why it is this? Once again we can see from this unit, kg is unit of mass. So here there is m symbol for mass, and its power is given here nothing. Nothing means it is always 1. So m raised to 1. Meter square is there, and meter is for length. So here symbol is L, and here power is 2. So here we have written square. Second is for time. So symbol for time, and here power is minus 2, and so it is here. And so we can say that the dimension of K is this. Let us give this equation number 1 so that we can compare the other with this given equation. Now given first one, m square v raised to 3. So dimension for that is mass. Symbol is m, there is square, so here it is square. Velocity is distance upon time. Upon means t raised to minus 1, and as there is cube, here we have written this cube, and then combining these two, finally we will get dimension as m raised to 2 L cube t raised to minus 3. You can easily get this result from this. Now I know there is no need for me to explain each and everything, because already I have explained these things to you. For second equation, that is number B, it is given half mv square, and as I said, numbers do not have any dimension, so here I have not written that. Now for mass it is m, for velocity it is L t raised to minus 1. Here there is square, so I have written here square. After opening these brackets and then combining this, you can easily get this dimension. I hope you will be able to understand this. Similarly, for next it is ma. For equation number C on right hand side, just go through it once again. It is this ma. So m, that is mass, acceleration is distance upon time square, so distance is L, and upon time square, so t raised to minus 2. Again combining this two and writing, we will get this as the dimension. Then equation number D, m v square, it is, you can say that same as this, so dimension will also be same, so I have written directly here. Then for equation number E, there are two terms on the right hand side. So for first term half mv square, we can write this, because already we have done for this also. See, mv square here also, mv square here, so this dimension is same as this. This half do not have any dimension, so no need to consider it. Then for ma, already we have obtained that dimension, so we can directly use this dimension here. Now Here you can see that this dimension and this dimension are different, and so this equation number E is not correct. Now we will check for these equations. Here for A, the dimension obtained is this. Compare that with the kinetic energy. You can see that these two are not equal. So this equation cannot be the equation for kinetic energy. Then number B, this dimension and this dimension, they are equal. So this equation can be the equation of kinetic energy. Even C, you can see that it is m1 l1 t raised to minus t, but here this is m1 l2 t raised to minus 2. So these two are not equal. Then D, this equation is equal to this, which is for kinetic energy. So this can be the equation of kinetic energy. So after comparison we found that these two can be the equation of kinetic energy, because these equations they match with the dimension of kinetic energy. Students, here you have seen that in this equation E, the dimensions of this term matches with the dimension of kinetic energy, but dimension of this term does not match with that of the kinetic energy. And for any equation to be correct dimensionally, all these terms should have same dimension. So I hope this thing is clear to you. Now our last topic number 2.10.2, deducing relation among the physical quantities. Means the dimensional analysis can also be used to obtain equation. Means we can make the formula also for any physical quantity in terms of other physical quantities. Now here in this example we have to obtain the formula for the periodic time of a simple pendulum. We know that the periodic time for a simple pendulum is given by T is equal to 2 pi root L by G. So even this type of formula can be made using this dimensional analysis. Students, there is one correction here. In place of can, here it is cannot. So make this correction in my notes. Now let us start this example. Here a simple pendulum is given. This is the length of this simple pendulum from this point to center of this bob. A bob have mass and acceleration due to gravity acts on it. So now here in the statement it is given that the periodic time of a simple pendulum can depend on the length of the simple pendulum, mass of the bob which is suspended, and the acceleration due to gravity. Means this T depends on these three physical quantities. And so as it depends on these three physical quantities, we can write that T is proportional to L into M into G, but we don't know what are their exponents, means their powers are not known to us. So here we have taken that as X for L, Y for M, and Z for G. whenever we remove this proportionality sign, there must be some constant, and here this constant which arises due to this proportionality, that is always dimensionless, means this constant does not have any dimension. Let us give this equation number 1. Now to obtain the equation of periodic time, we need to find these exponents, that is x, y and z. For this, what we have to do? We have to compare the dimension on both the sides, that is on this left side as well as on this right hand side. On left hand side, the dimension of t, that is time only, so we can write it as m naught l naught t raised to 1. You know that how we can obtain it. Then on right hand side, the dimension of l, its power is x, dimension of m, power is y, dimension of g, power is z. But what is l? It is a length, so symbol is l, and power is x. Mass, symbolically we can write as m for the dimension, and power is y. Acceleration due to gravity, it is acceleration only, so it is distance upon time square. We have obtained the dimensions for acceleration in our previous topic in that examples. So we have written for acceleration L1 t raised to minus 2, power is z. Now combining this, we have written first L, m and t. It is not necessary, you can write first m then l then t, or first t then m l. Order is not important. Now for l, here the power is x, x into 1 is x only. There is one more l here, z into 1 z. So here power of l is x and here the power of l is z. So combining these two powers, we can say that power of l or the exponents of l is x plus z. Mass is only 1 here and its power is y. So simply m raised to y. T is here only and its power is this, that is z into minus 2, means it is minus 2z. So on the right hand side we obtained this. Now comparing left hand side and right hand side, students carefully see here. Now when we compare the power of m here and that here, we can say here it is y and here it is 0. So directly we obtained this y, that is y is equal to 0. You can see I have written here. Then we will compare power of t. You can see here it is minus 2z and here it is 1. So comparing we get minus 2z is equal to 1. So I have written same here, minus 2z is equal to 1, and then making the subject z, we can bring this minus 2 towards right hand side. So finally we'll get z is equal to minus 1 by 2, and then only remain to compare l. Here the power of l is x plus z and here it is 0. So we can say that x plus z is equal to 0. So for this we have written here x plus z is equal to 0, And so what is x? We can bring this z towards this side, so it will become minus z, but the value of z is minus 1 by 2. So here value of z is kept, but minus into minus becomes plus. So we get finally x is equal to 1 by 2. So now we have value of y, we have value of z, and that of x. Using these values in equation number 1, that is this equation, what we will get? We will get this term, t is equal to k l raised to 1 by 2 m raised to 0 and g raised to minus 1 by 2. Now m raised to 0 means it is 1 only, so we will not write anything for that. K as it is, and anything raised to 1 by 2 means it is root. If I say x raised to 1 by 2 is there, then it is root of x. So we are going to use that concept also. But here the power of L is also 1 by 2 and that of G is also 1 by 2, but it is inverse, minus is there. So we can write that power 1 by 2 common, but G is inverse of that. So L by G raised to 1 by 2. I hope you can understand this easily. And if the power is 1 by 2, we can write that in under root form or square root form. So we got this equation of t. Now students, we know that the equation of periodic time has 2 pi here in the multiple, that is as a constant, but here it is k. So by using this dimensional analysis, we can get this type of formula, but the value of constant k cannot be determined with the help of this method of dimension. If we want the value of k, then that can be obtained using experiment. So now experimentally value of k is obtained to be 2 pi. Remember, this cannot be obtained with the help of this dimensional analysis, but by doing experiment we can get this constant. And so finally we can write t is equal to 2 pi root L by G. If you write up to this much in the exam, then also it is correct. But if you know what is this constant in this equation, then I will advise you to write till here. So now students, I hope you are able to understand this. If any doubt is there, you can definitely ask me. And exercise of textbook you have to do yourself. Don't do additional exercise, that is not compulsory, but make one correction here. In place of can, it is can not.